Hello students, welcome to the new video that is on the power plant that we are learning about the engine of the 2 and 3 wheeler in the case of the TTWT subject. Now until now we have seen almost all the components that is required to keep the running engine. Also we saw about the lubrication system that is required to keep the lubrication in the engine, also to provide the cooling in the engine, and also to reduce the friction in the engine, because almost all the components in the engine are the reciprocating components. In this video we will see about the scavenging process that is required in the case of two-stroke engine, and it will generally be most important case of the petrol engine, right? Because in case of the petrol engine, what we are supplying in the engine is fuel plus air, right? We are supplying from the either from the pot or from the valve, that is petrol plus air. So if our petrol is exhausted with the exhaust gases that is generated in the engine, then we will lose our petrol that is not even burned. We have not used its energy. So overall the average of the engine will reduce if we are not providing the scavenging process in case of the petrol engine, and mostly in case of the two-stroke engine, the valve overlapping that we saw in the earlier videos, that the valve overlapping, in which case the transfer port and the exhaust port are open simultaneously. So in that case both the valves are open at the same time, so there are chances that the inlet charge goes outside with the exhaust gases via an exhaust port. So in that case we require the scavenging process. What scavenging process provides is that, you can see right now, is that inlet charge forces the exhaust gases outside via the exhaust valve. For that, what we will have to do is that we will have to pressurize the inlet charge before supplying it into the engine. Because of the high pressure that has been in the inlet charge, the exhaust gases will be forced out. That can only be achieved by the pressurizing of the inlet charge. So what we do in the two-stroke engine is that first we take the charge from the inlet port. After inlet port, first charge comes below the piston in the crankcase. So when piston comes from TDC to BDC during the suction stroke, what happens simultaneously is that charge which has been come from the inlet port is being compressed below the piston. That compressed charge during the compression stroke goes from the transfer port, and when the time arises, the transfer port supplies the fuel into the cylinder part where the combustion is required to be done. So when the fuel comes in the cylinder head, what will be the pressure of the fuel will be? So it will be higher than the atmospheric pressure, because the fuel is pressurized below the piston. So this is how simply this process works in case of the scavenging process. So scavenging process is required because the inlet charge and exhaust gas charge is overlapping, right? So both the things or both the ports are open at the same time. So if we don't do this, then we will lose our petrol and the value of our vehicle mileage will reduce. Second thing is, it is mostly required in case of the two-stroke engine. As I told you earlier, that the valve overlapping time in case of the two-stroke engine is very much higher compared to the four-stroke engine. It is almost around 70 to 90 degrees of the crank angles. Next thing is, the petrol will waste if we are not doing the scavenging process in the engine, or in case of the two-stroke or four-stroke petrol engine. We will force the exhaust gases by the pressure of the inlet charge, right? As I have already told you, we will first pressurize the inlet charge, and because of the high pressure inlet charge, the exhaust gases will be forced out from the exhaust port. In case of the diesel engine, what we are supplying is only the compressed air via the transfer port or via the inlet valve, right? So if the air is going out with the exhaust valve, then there will not be much of the problem, because the fuel will not be wasted, right? So scavenging will also be done in the case of the diesel engine as well to force out the exhaust gases. But if we are losing the air, then there will not be much problem, because we are not losing the diesel, we are just only losing the air during the process of the diesel engine. Next, there are several methods to achieve the scavenging in the petrol engine, or in the case of the two-stroke engine. There are mainly three types of the scavenging method that can be used in the engine. The first one is the cross-flow scavenging, in which the flow of the exhaust and inlet gases will be opposite to each other, and the fuel will have to go round to force out the exhaust gases. The second one is the loop scavenging, in which the fuel or the charge that which is entering in the engine will have to create one loop to get the exhaust gases out of the engine. And the third one is the uniflow scavenging, in which the direction of the inlet charge and the exhaust gases will be similar, or will go in the same direction. That is why it is known as the uniflow scavenging. Let's see how the flows in this scavenging process work. In the first figure, you can see the cross flow scavenging, in which you can see from the transfer port, the fuel and air mixture, that is, we can say the charge that comes from the transfer port. From the transfer port, it goes on top of the cylinder head. From that cylinder head, it goes again downward side, and during the downward motion, the exhaust gases is exempted in the right side direction, right? So the fuel has to grow in the cross direction and not in the same direction of the exhaust gases. So this is first method, that is cross flow scavenging. The second one is the uniflow scavenging. In the case of the uniflow scavenging, you can see that the flow or the inlet charge from the transfer port comes in the vertical or upward direction, and to match the uniflow or to get the similar direction, we have provided the exhaust port in topmost position in front of the spark plug, right? Such has been given in the 4-stroke engine in the case of the exhaust valve. So from that we can say that from transfer port, the fuel will go on the vertical direction. Also in the same direction, exhaust gases needs to be exempted. So in the same direction, the exhaust gases will be forced out from the engine. So in case of the uniflow scavenging, there are chances of mixing the air with the exhaust gases, because both of them are going in the same direction. In the last figure, you can see the loop flow scavenging. In the loop flow scavenging, you can see that the exhaust and inlet port are given in the same direction or side by side. In the first figure, you can see the inlet is on the left side, exhaust is on the right side. But in the case of the loop flow, both are given on the left side. One is the bottom of the other. So from the transfer port, the gases will come, it will create one whole loop, and after completing the loop, it will force out the exhaust gases from the engine. Generally in the 2-stroke engines, we either use cross flow scavenging or loop flow scavenging, which gives us the better performance for the scavenging process in the case of the 2-stroke engine. So these three are the methods that is basically used to provide the scavenging in the engine. To provide the scavenging, first we will have to pressurize the charge below the piston. After pressurizing the charge, one of this method can be used to provide the scavenging in the engine. Now you can see here the scavenging process that is generally done. We will see two, that is cross flow and the loop flow, how it will be happening in the engine. So here the engine process, you can see the transfer port is the left side and the exhaust port is on the right side. So how this scavenging method works is that the fuel will come from the transfer port, which will be pressurized. That pressurized fuel will force out the exhaust gases from the cylinder, right? This is how the normal scavenging works. We will see about the cross flow and the loop scavenging in this. You can see right now the cross flow scavenging that is happening. From the left side, transfer port provides the inlet charge, and that inlet charge forces the exhaust gases by opposite direction flowing of the inlet charge and exhaust gases. It forces our gases outside. The second one is the loop scavenging pin that you can see from the behind of the piston. The inlet port or the transfer port is provided. From that the inlet charge comes, and that inlet charge provides the same direction or the loop of the fuel plus air, and that loop forces the exhaust gases outside the engine. One important thing is in the two-stroke engine is that the piston will be provided with a crown shape. The piston will not be flat, as you saw in this video, and that the shape of the piston was the crown shape. The crown shape provides the proper force and proper direction to our fuel flow, so that the exhaust gases and fuels does not get mixed with each other because of the shape of the piston. Right, so in this video we saw about the scavenging processes that is required mostly in case of the two-stroke petrol engines. In the next video we will see about the cranking mechanism that is required for the engine. Until then, thank you so much.